Hello, my name's Colin, and welcome to Wireless Communication Tech. We're going to do a quick run through on radio system types, specifically two-way radio system types, mainly so we can answer the question of what is trunking and try and help viewers understand what trunking systems are. But we're going to step it through the different types of systems out there, two-way radio systems in general. So let's get started. As any animation or image you see in this is going to have been provided by Zetron using their Codan manuals, and I will link those in the description so you can find them for yourself and read through them. There's a lot of good info in those. So let's get started. So the first most basic type of radio system out there is the direct communication system. So each user has direct radio-to-radio communication with one another. You can configure it with a base station dispatching from a advantageous location, but it can be problematic if not all users are in direct range of one another, due to terrain or whatever. And this illustration really shows the office building can talk to the portables, but because of the hill, they can't talk to the mobile. Nobody can talk to the mobile. So we're going to move on with our next type, but you will see direct systems used often for fireground and sometimes just establishing local communications. Sometimes you'll see amateur operators refer to this as simplex communications as well. It means the same thing. So now we have our conventional repeated system. Whenever you hear the phrase repeater, this is typically what this refers to. And it's used to extend communications from an advantageous location. Essentially, it functions by taking the received signal, demodulating it into its audio or digital component, and then just retransmits that information. As you can see here, we have a setup where we have a repeater up on a hill, and it's providing coverage to two portables and a mobile, with one portable being on the other side of the hill where it wouldn't have traditional direct communication capabilities. One of the other things you can do with a conventional repeated system is you can dispatch it via a wire line through the repeater, so a direct connection to the transmitter of the repeater through a audio interface, essentially, or you can dispatch it via RF through another radio, what is commonly referred to as a control station, that is local to the dispatch center. Our next available option is what we call a voted receive system. Essentially, we have multiple locations where we have receivers all monitoring the same frequency, and then a central location where we have our transmitter. A signal quality check is performed on the incoming signal, whether that be signal to noise ratio, bit error rate, or whatever, and it's compared and then voted on for the best quality audio or signal. The device that actually does this comparison is called a voter comparator, and the voted signal source can change dynamically during the reception of a signal, so you can move from one site to the next in the middle of the signal without the signal dropping out. So the next one is, and this is going to be more or less a definition for land mobile radio in North America, which is simulcast. So in simulcast systems, you have multiple transmitters on the same frequency, and they often have overlapping coverage, as you can see in the diagram. There's a purple grid area where the blue and the red are overlapping. Now, typically, if you have two transmitters on the same frequency that are overlapping, you're going to get a distorted audio, which is shown in this diagram, where transmit A is and transmit B are in different phases, and when you actually mix that, as you can see, the amplitude is lower and the phase is even shifted again, which will give us audio distortion. So the phase timing is extremely critical to these systems to prevent that distortion. And there's typically going to be a synchronized clock at each transmitter site that defines the timing for the simulcast. Today, there's a way to do it to where you don't have to do it over a clock at each site using a protocol called PTP, Precision Time Protocol. But to the best of my knowledge, in April of 2026, there is not a manufacturer of a simulcast solution that is currently using PTP across your links. There may be a manufacturer that is using PTP from the site clock to the equipment itself, but not across the master link. So of course, because you have more equipment, this has a increased cost for the infrastructure, and because on digital systems we're moving from frequency shift keying to phase shift keying, there is an added expense with the infrastructure there. You know, we have to change the amplifiers that we're using and some other important little details. But it does reduce the frequency requirements to provide that extended coverage. So instead of having multiple sites on different frequencies, you are just reusing the same frequency, except you still have to coordinate that with your coordinating body when it comes to your frequency use. So next is a simulcast with voting. This is essentially you have voting available at those sites as well, and it's pretty common to see this today. But in this diagram, you can also see that we have delayed transmit B so that the signal is completely within phase of transmit A, and we get a much stronger signal in phase, no distortion at the receive end. So that's essentially how simulcast works. I've heard it put as voodoo by people outside of North America, but and we typically see it mixed with voting on modern digital systems. You might still see some standalone voting, but typically if you say simulcast, you're always going to mix it with voting in most of your modern deployments. Next is our multicast system. So this is your traditional multi-site system where you have multiple transmit and receive frequencies, and the sites can operate independently of one another with that call audio being passed across the system. This is actually a fail-safe feature for that a link failure. So you still have a functional repeater local instead of having a repeater that receives but doesn't transmit any audio because the site you're transmitting to has no link. So that's kind of considered better to have at least local repeat capabilities instead of zero repeat capability at all. You typically don't see these sites using the same uplink or downlink frequencies, but you can accomplish that either with geographic separation to where you have no overlapping coverage, or with some access control methods like CTCSS, DCS, NAC, or color code, or RAN differences. You can work it out a little better, but you still have some issues where you might see some interference if you have overlapping coverage. One downside to this is the end user may have to change channels on their radios, but that's going to be highly dependent on the subscriber technology available, such as if the end user's radio supports a feature called roaming or vote scan, which is available in most of your higher end products, but it is in some cases you have to option it extra. And then now we have the big one. What is trunking? So trunking is the dynamic allocation of channel resources based on the probability that not all groups will need a channel at the same time. So it works on the basic concept of the next available channel goes to the next user. An example is if you're checking out at a busy Walmart and you pick your checkout lane with your cashier that you want to use, and then you get stuck behind somebody that's, stocking up for the month, and you can't check out until they've gotten checking out done. A great example of this is in a lot of rural environments, you have a law repeater and a fire EMS repeater. Well, in some cases, in those rural environments, you have what we call volunteer services. So your fire departments are often volunteer, and they may not be as disciplined on the radio, and so you may run into a scenario where your law resources at a scene they've got everything blocked off, and they're just kind of sitting watching the show at this moment. They're not using their repeater, but because you're EMS and you need to send an important patient update, you can't get it through because fire's over there. The volleys are over there sitting and talking about putting the wet stuff on the red stuff. It happens, but your options are essentially go yell at the IC that you need the channel and see how well that goes. It's not going to go well, or just wait. So you got to wait. The alternative to that is with trunking, you look at it more like you have a self-checkout. You form a line, which is a queue, and as soon as a kiosk is available, you move over to it. You might have a director, an employee that is saying, hey, this kiosk is open, go to there. That would be your trunking controller. But as soon as it is free, the next person in the line can go. If there's no line, you just go straight in with no wait and get your channel. But this is how trunking is designed, though there's some additional stuff to it in terms of priorities. But it's, the next person essentially gets the next available channel. So back to our whole EMS scene needing to send a update. Well, fire's using the channel currently and they're talking. Well, as I already said though, PD's not using it. Well, a trunking controller would say, hey, use the PD channel to send your message. And you'll get your message through. PD doesn't need it at the moment, and the message goes through. That's trunking in a nutshell. So finally, we have our trunking system types. The most basic trunking system type you're going to run into is a standalone system. This means that the system is not connected with other sites. There may be some direct interfaces at the system level with dispatch consoles, but you don't have any other RF sites. It's going to be a single transmit and receive site. Next, you run into your voted systems. These aren't as common. You do occasionally see them with things like DMR and XDN, where they just needed a little extra receive coverage input. And then we have our simulcast site, which is, in terms of trunking, is always going to be combined with voting. And from the end user's perspective, on a simulcast system, and this applies to the conventional as well, it is always going to look at as one RF site. There's never going to be any end user input for going between the different subsites within that cell. Finally, we have our wide area trunking systems. These are your large multi-site systems. It is a multicast-based system, and it has multiple transmit and receive sites which carry traffic across those sites simultaneously. It can contain multiple simulcast cells within a multicast system or within the wide area system, and it can be a mix of wide area multicast sites and simulcast cells. It can be a mix of multiple simulcast cells. You can reuse frequencies as long as there's no overlapping coverage, unless we're within that simulcast cell. And the radio will typically roam from one site to the next without any user intervention, as long as the what we call the talk groups are provisioned at those sites. That pretty much is a basic quick wrap up of how these basic radio systems work. Trunking can get very advanced, and like I said, you have these massively large systems with 100, 150, sometimes as many as 400 RF sites to cover an entire state. And your trunking systems can be made up of multiple channels, upwards of 30 if we're using a phase 1 system, or a system that does not divide everything into TDMA. But we will discuss that at a later video. I really want to talk more on simulcast in a later video, because there is some very unique magic that happens there that just blows people's mind when I start explaining it, especially if you're not from North America and don't have a real good practical system to base your knowledge off of. So anyway, thank you for watching this video, and we hope to catch you in the next one.